MacMaths. Let's do some maths today. Statistics. Okay, so today I'm just going to talk about quartiles. Just remind you of what they are, why we have them, how we find them for discrete and continuous data. But actually this is about support with exercise 2C in the statistics course. So that's what this main lesson is about. Just very quickly, you know what quartiles are. Let me give you an example of where they're used and why we have them. Say for instance a supplier, a farmer, wanted to supply a supermarket, let's go posh and go Marks and Spencer's, with apples. So what they would do is they may sell a couple of tons of apples to Marks and Spencer's. So Marks and Spencer's would do a quality control before they bought those apples, and they would ask for a sample of apples. And when they get a sample of apples, poured out, maybe, I don't know, a couple of hundred apples, they want some information about those apples, like the average size and so on, and the range of the weights. Because Marks and Spencer's know that when they put their apples out, say in a box or in a tray for people to buy, the loose ones, say, to put in a bag, customers would only choose apples that are sort of the same size. They're not going to choose one that's really small, are they? Okay, so so those ones will get left over or left behind, and they'd be wastage, and actually they don't look good for they're a posh supermarket having small shriveled up apples in the box left over. Or if Marks and Spencer's are packing them themselves in those nice little trays that are bad for the environment and putting all the apples in the same size, they want all their apples the same size, so they want no wastage. So when they ask for data about those apples, they want to know that those apples, on average, there's my apple there, are the size that they want, whatever that is, I don't know. Okay, so the size of the apple that they want, and they want to know that the range of those apples, the sizes of those apples, is quite small, because they want, if the range is small, then they're all a similar size. Okay, and they can sell most of those. So the problem with the range is if the supplier or the person looking at the sample looks at the range, the chances are if they're looking at a sample of a couple of hundred apples, in that sample there might be just one or two little piddly small ones like that. Okay, and there might only be one or two of them, but what that does is it makes it then look like a big range. If there's going from small to sort of the largest, it looks like a big range, and it might give a distorted view of the sample, so that they may just be outliers. So what is more likely is that the Marks and Spencer's will ask for the interquartile range. They're called Quartile One and Quartile Three. Quartile Two, of course, is the median, the middle. Okay, so 1 quarter, 2 quarters, 3 quarters. So they ask for the interquartile range. Now, if that is very small, the interquartile range, it means that most of the apple, well, 50% of the apples are all the same, roughly the same size. So they could, the sample, it's a better look for the sample. There might only be a few apples outside of that. Okay, more often than not, probably suppliers go for a different percentile, not the quartiles, which are of course 25% and 75%. They may go 10% each side, so a 10% quartile and a 90% quartile, so 10 and 9. So they're just knocking off the smallest 10% and the biggest 10% to see whether there's consistency within those, and that will get rid of all of your outliers if there are any, wouldn't it? Okay. Quartiles, when you talk about interquartile range and quartiles, they usually have this capital Q, and the first quartile, at 25%, is usually labelled Q1, Q2 for the median, and Q3 for 75%. Other percentiles, you often see a capital P with like a 10 for 10% or 20 for 20% and so on. Okay. The way that we calculate quartiles for discrete and continuous data. Let me just talk about how we do that. Okay, for discrete data, the quartile 2, and that's the median, the middle, you do your n plus 1 divided by 2. So if you had 31 apples, you go 31, add 1 is 32, divided by 2, you want this the weight of the 16th apple. Or if there's 30 apples, 30 add 1 is 31, the 15.5 fifth apple. So that is halfway, the weight that's halfway between the 15th and the 16th apple. So you know that. The quartile 1 and the quartile 3 though, when you are doing discrete data, when it's exact values, what you do is you just go n divided by 4, and then if you look at the rule, there's some mathematicians have decided on some rules of this. If it's a whole number, if whole, you move up halfway. Okay, so you move halfway up. And what that means is, so if you had 16 in your sample, you divide it by 4, 16 divided by 4 would be 4, and then you move half, so you find the 4.5 bit of data, so halfway between the 4th and the 5th, and that would be your lower quartile. Okay, but if it's not whole, you round up. Okay, so for instance, if you had 17 in your sample, you divide by 4, and when you divide by 4 you get 4 point something, so you take the 5th value. Okay, you just round up if it's not whole. If it is a whole number, you go exactly halfway up. Okay, and it's the same with Q3. You just go 3n over 4, obviously, so n over 4 and then times the whole thing by 3. If it's whole, halfway up, and if it's not whole, you just round up. Okay, if you get 7.3, for instance, you take the 8th value. Okay, if it goes down this line. Continuous data is easy. So Q2, the median, oops, you just go n over 2, and Q1, you just go n over 4, and Q3, you just go 3n over 4. It is only an estimate, so you don't have to go n plus 1 divided by 2, you just halve it, and that's the middle, quarter it. And this is what we're dealing with most of the time, probably, is continuous data. Okay. If you're finding percentiles, again, continuous data, 90%, you just find 90%, as you do here. You're just finding a half, 25%, 75%, so on. Okay. Discrete data, you don't really get asked for beyond median, Q1 and Q3. Okay. All right. So we're going to apply this now to some of those questions. There is a problem with one of the questions, and I'm going to talk you through that. So we're going to look at exercise 2C now. So that's on page, just have a look, 27 in the book. Let me just move that book down. So I've got that there for me. So this is the exercise I'm sort of going to go through. It's just start with just some discrete data here. You know, really simple, putting them in order and finding a median in the lower quartile. So we'll do that one. Problem with question 2, I'll talk about that. Sorry, not a problem with question 2, problem with question 3, but I'm going to go through a bit of that one and talk about the last one as well. Okay, so that will help you with this, and then you can go away and you know, you can have a go at that exercise first if you want, but I would say that don't do question 3, and I'll explain why. Okay, so here we go. This is the data, the question. So I've put the tables for question 1, 4, 5 and 6 that I'm going to be sort of talking about. If you look at the first question, the simplest question in the exercise, it's giving you these numbers here, 1024, 1022. These are HP. There's that the pressure, what I can't even remember what it stands for now, hectopascals or something. I don't know, I'm just making anything up now, but anyway, it's the pressure. It's from that large database. And it's the pressure measured each day for the last 16 days in July, whatever, and it says find the median pressure, so we need to put all those numbers in order. Okay, if you are doing that, okay, you can see here that they all start with 1,000 and 1,024. So when I'm putting them in order, I'm going to forget the 1,000 bit. I'm just going to, common sense, I'm just going to put the last two digits as Mueller. So I'm ordering 24, 22, 21, 13 and so on. Okay, so let's do that. So I'm going to go, that's the smallest 09. Now I've done this, and I'll be honest with you, I made a mistake ordering these, which is so easy to do. So it's almost impossible to order them without making a mistake first time, missing one out and having to squeeze it in. So do be very, very careful. And of course, at the end, add up all the numbers that you've got and make sure that you've got 16. So in order, it's 9, 13, 14, 17, 17, 17, 18. The reason I'm writing messily is because I'm looking at the list that I've done, because I've done a sort of do this 25, 27, 29 and 31, and just as a check, this is meant to be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. There you go. So 16 numbers. And what do we have to do? We have to find out, the question just says the median and the upper and lower quartiles, so not the interquartile range. We don't have to do the takeaway. So Q1 and Q3. Okay, so Q2, Q1 and Q3. Okay, so 16 numbers. So we apply, because this is discrete data, so we go n plus 1 divided by 2. Okay, for the median. 16 add 1 is 17. Half of 17 is 8.5. So 1, 2, 3, 4, 5, 6, 7, 8.5 is halfway between 19 and 21. Okay, which is 20. But remember, don't do that, I'll make that mistake on the exam and put 20. It's 1,020, isn't it? Okay. When you go 17 divided by 4, let's do Q1. 17 divided by 4 is obviously 4 point something. And because it's 4 point something, let's just check what that is. 17 divided by, in fact, what am I doing here? It's 4.25, isn't it? 4.25. Q1 is the 4.25th figure. Okay, and what we do is, because this is a decimal, we round up. Let's get rid of that bracket actually. We round up to the 5th, because that's the rules. So we want the 5th data. 1, 2, 3, 4, 5. So it's 17. Okay, oops. 1,070. And Q3, the same thing. If we times that by 3, we get 12.75. So we round up to the 13th. The 13th. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, which is 25. Oops, done it again. What an idiot. 1,025. Be careful with that. Okay. And that's the first question. So just using those rules of n plus 1 divided by 2, and then the little rule that we talked about. So make sure you remember that. Okay. All right, so that was question 1. Okay. Now there's a bit more maths to come now, so a bit of proper A-level maths is starting to creep in. I'm going to miss out question 2 because it's discrete data, and you just find in Q1, 2 and 3, so that's okay. It's in a table, so it's not a problem. But question 3, I am going to talk about a second with you. Question 3 is, if you do question 3, you may or may not get the answer that they get in the back. It's this here. I'll talk about it now, but I'm not going to do it because I disagree with the answer in the back. And it has the number of breakdowns. So it's a good discussion, this one, for you to see, and the frequency. And it says the number of breakdowns is 0 to 1, 2 to 3, 4 to 5, and 18 7 and 1. So this is, it talks about the question saying the number of breakdowns in a week that a hotel has for its lift. Okay, so it does it over 18 as it's 25. It does it over 26 weeks. It's a 26-week period, and each week it looks at the end of the week. It says how many breakdowns have we had. So 18 times it had either no breakdowns or one breakdown recorded at the end of that week. Okay, so that's the data. Now this is discrete data, so it either has no breakdowns or one breakdown, and it says give an estimate. The question is asking you to give an estimate for the median. Okay, that's what the question is doing. Use interpolation. It tells you to use interpolation for the median. All right, so what the book does is it halves that to give you 13. Okay, so it says it's the 13th position, and by doing that, what the book is doing is saying that this is continuous data. And what they've done in the back, to get the answer in the back, they have said that 0 to 1 has that class width, we talked about this in the last lesson, of 0 to 1.5, in other words halfway to this. So it's saying 1.5, and this width, so this group here is from 1.5 to 3.5. That would only be the case if this was continuous data, and it's not. It is discrete data. In other words, these noughts and ones here, remember, are a list of noughts at the end of the week, or ones, and there's 18 of them. We don't know how many. I mean, I would, if it was an estimate, say it's fair if there's 18 to say 9 zeros and 9 ones, and the median, an estimate for the median would be 1, because that would be the 13th position, or 13 and a half, halfway between the 13th and the 14th. But the back does it does by interpolation, the 13th dividing 0 to 1.5. So it divides 1.5 up by 18 and 13 lots of that, and it gives you an answer of 1.08. And I disagree with that, because this is not continuous data, and it does not look reasonable to me. Okay, that's how they've done it. I did speak it through with Mr. Orme and Miss Scopes as well, and I managed unbelievably to convince them that that I was right and the book was wrong, and they agreed. Or they said, I don't disagree with you. That's the same thing, isn't it? I'll take that. Okay, so that's what I think anyway. You may think something different, but that's what I think. Question 4. If I put it there now, you can sort of see that question 4. So we're looking at that one there. Question 4, I'll only do the first sort of bit of that one because it's all the same. If you add up the frequency here, the frequency adds up to 31. And these are weights in kilograms, put that in, of Jersey cows. Okay, so the weights in kilograms of Jersey cows. And we've got to find an estimate for the median. Okay, so the question A says it wants the median. B says it wants the lower quartile. C says quartile 3, and D says I'll talk about D. Interpret meaning for part C. Okay. Let's just do the median. That's fine. It's continuous data. Okay. It's continuous data. So we're going to go. There's 31. We're just going to halve that figure. Okay. So let's do this one here. So the Q2 is going to be 31 divided by 2, which is the 15.5th position. So we want the 15.5th. It's not discrete, we're not going to round up or anything like that. The 15.5th. Which group does this lie in? First 3 are there, cumulative. 6 makes 9. The first 9 are there. The next 10 are in that. That takes us past them, you know, up to the 19th, and we want the 15th. So the 15.5th is in this group, is this group that we want. Okay? So let's have a look at this group. So this group goes from, remember, so because these cows have been rounded, they've not done it with the greater and less than signs, which is a better way of doing it, isn't it? They've been rounded down to the nearest, or up to the nearest kilogram, which means that this group goes from 399.5 to 449.5. Okay, so if we just do it very quick, we should get 51, shouldn't we? 0.5 up to 400, yeah. Oh no, hang on. 449.5, I'm just checking. 449.5 minus 399.5 is equal to, oh, 50, be careful. Okay, so there's a class width of 50. And in that class width of 50, there are 10 cows. Okay, so we do 50 divided by 10, okay, which is 5. So each interval, you know, we're saying that the cows are evenly weighted right the way through that. So every 5 kilograms, you've got a cow. Okay. Now then, what about our position? So we've got 15.5. Okay, we've got to find the 15. The first 9 are here, so we want into this group here. There's already 9 cows here, so we want the 15.5th cow, so we want 6.5 cows into this group, and each cow is 5 kilograms more than the last one. Okay, because that's, each bit is split into, you know, 10 lots of 5, so we times that by 5, and that gives us 6.5 times 5, 6.5 times 5 gives us 32.5. Okay, and it's 32.5 into this group. So this group starts from 399.5, so we've got to add that 32.5 to it. So that plus 399.5, and that gives us 432. So therefore our 432 kilograms, that is, I hope it's on the screen, it does, that is our median cow. Okay, and if we were doing the quartile one, I'm not going to do that one, but we go 31 divided by 4. Okay, 31 divided by 4 is equal to 7.75. 3, so 7.75 would be in this group. This group is starts at 3. It starts at 349.5. You know, half before that, and so you are doing take off 3 from your 7.75 is 4 point. So you're going 4.75 into this group. So you're dividing 50 up by 6. It's not going to be a nice whole number, but that's how you do it. Okay, that's how you do it. Once you found the quartile 3, you found effectively the 75th percentile. So when it says interpret the meaning for part C, all you're saying is that whatever you get there, whatever weight you get, you are saying that 75% of the cows are less than that weight. That's all it is. Or you were saying there are only 25% of the cows that are bigger than that particular weight, the quartile 3. That's all it said. That's all you have to put for that. That's what the meaning is. Okay. So that is the first part of question 4a. So I'm sure you can go on and do that the rest yourself. Message me if you can't. Okay. Question 5. Question 5 is this one here. So it says, find an estimate for the mean, okay. It says B, that's A, B is the 65th percentile, we're going to find, okay. And then there's a part C to this. So it says the firm writes in an advert only 10% of our customers wait longer than 56 minutes. Okay, so this is waiting time in a doctor's or something like that. Is it? What is it? Roadside assistance. So you break down, and this is the waiting time. So 6 people had to wait between 20 and 30 minutes to get rescued is what this is about. Okay, and this is what they're claiming, this roadside assistance. This is for part C, and it says by calculating a suitable percentile, there's a different way of doing it, calculating a suitable percentile. Okay, do that question. So, all right, here we go. Estimated mean, I did that. So, first of all, so that's just midpoint times frequency, midpoint times frequency, midpoint times frequency, and divide by how many there are. And I can't remember how many there are. So, 16, 24, 34, 35, 36, 37, 47, 47, 48, 49, 49 people. Anyway, when you do all of that, estimated mean, we've done that, we did that on the last lesson, it gives you 44 minutes. Okay. Calculate the 65th percentile. So let's do that, the 65th percentile. So this is P65, you might see it written like that, the 65th percentile. So 65%. So I'm just going to check again that I've added that up and there are 49, because if I've got that wrong, then I'm in trouble, aren't I? 10 plus, I don't trust myself, because I'm old, it is 49. So we want 65, but the first thing that we're going to do is go 65% of 49.65, and that gives us 31.85. So the 65% is the 31.85th person waiting, okay, when they're all in order. So let's find out what group that's in. Okay, so 6 there, 10 there, 16. 16 add 18 is 34. Okay, so that's past this one. So it's in this group here. So we want this group here. It's continuous, and they've done it nice, and it's 40 to 50, so it's 10. So in this group of 40 to 50, okay, there's 18 people, there's 18 people, and the bandwidth is 10, isn't it? Okay, so we're doing 10 divided by 18, that's what we're doing, okay? And when we get that, we've got, before this group, we've got 10 and 6 is 16, okay? So 16, what else to get, so 16 are in this group. How many do we want to go from this 40 line into there? Okay, so if we take 16 off this 31.85th position, 31.85th minus 16, it gives us 15.85. So we want the 15.85th person in this group, don't we? Because 16 have already gone in this one and this one. So we want 15.85. So we want each bit of this is the 10 divided by 18. That's each little bit is 10/18ths all the way along. And we want 15.85 of them. So we want 15.85. And when we get that, we know how far to go into this group. So we either add that onto the 40, don't we? So we're going to get it, do it all in one go and add it onto the 40. And if we do that, so 10 divided by 18 times 15.85 is equal to, and then we add that to the 40 and it tells us where it is in that group. And it's 48.8. So the 65th percentile is 48.8 minutes. Okay? If I interpret what that means, it means that 65 of the people had to waited less than 48.8 minutes. And 35 makes 100, so 35% of the people waited longer than 48.8 minutes. Okay, that's interpreting that as a figure. There's different ways of doing this one now. You can actually work out the position of 56 minutes, which is actually quicker and easier to do. Because 56 minutes is just 6/10 into this group, so you can work out what percentage that would be. But actually, it's not. The question is saying by calculating a suitable percentile. So by doing it their way, it's saying only 10% of our customers wait longer than 56 minutes. So what we want to calculate is the P90, the 90th percentile. Okay, because at the 90th percentile, once you've got the 90th percentile, you're saying that 10% work more, wait longer than that. So let's find that 90th percentile. And if they're telling the truth, that 90th percentile should be 56 minutes, shouldn't it? Okay. So the 90th percentile is 0.9, isn't it, of 49 people. Okay. So we'll do that, 0.9 of 49, and when we do that, we get 44.1. So the 44.1th person. The 44.1th person is actually in this group here. Okay, so 6 add 10 is 16, add 18 is 34. 34 takes us up to, from 34 up to the 47th. Okay, so there's 34 people in here. So if we take 34 off that, we get the 10.1th person. Okay, we get the 10.1th person in, this is part C, in this group here. Okay, so out of those 13 people in this group, we want the 10.1th person in that group as an estimate. Okay, and then we've got the, we know that the first 34 here are in these groups, and then the next 10 take us to the 44.1, and that's the 90th percentile. Okay, so this group is 50 to 60. To 60. See the way I do it? I always do it like that. I always put my width on the top, and then how many are we splitting it into? We're splitting it into 13. So we do 10 divided by 13. It gives you the fraction, doesn't it? Set it out like that way. Okay, imagine that's 13 spaces. So we want 10 13ths. Each one of these is 10 13ths. And how many of those do we want? We want 10.1 of them. So times 10.1 of them. Okay, and when we've done that into there, we need to add it to 50 minutes to see whereabouts in that group 50 to 60. We're hoping that they're right and they're not telling fibs here. We're hoping that's going to give us 56. Okay, so when we add it to 50, when we get the answer to that and add it to the 50 minutes. Okay, so we're going to go 10 divided by 13 times 10.1 and add 50, and it gives us 57.7. Okay, so let's interpret that. They're saying only 10% of their customers had to wait longer than 56 minutes. But it's not true, because actually 10% of their customers had to wait longer than 57.7 minutes, almost 58 minutes, so longer than what they said. So they're effectively saying 90% of their customers waited less than 56 minutes. They didn't. 90% of their customers waited less than 57.7, so a bit longer than what they are claiming. They're not far away, but it's not the truth, is it? You know, to make it sort of fair, they should really be saying 58 minutes. You know, that would be more accurate. Only 10% of our customers have to wait longer than 58 minutes. Would have been a fairer claim, not 56. They've just cheated a little bit. Okay. All right. So that's that one. Part C. And then the last one. I'm not going to do the last one, but I just wanted to, because there's something just a little bit different from this one. Here it is. Estimate the 80th. You can see I've missed out the middle bit of the table. The 80th percentile, you know, will be in this group, I think, or this one, I don't know. It's just doing what we've done on the last one. But part B, it says state why it's not possible to estimate the 90th percentile. Okay. This is a table that gives you the wingspan of, I think they're condors, those great big birds. One escaped from Warwick Castle, didn't it, the other day? And one of them, Californian condors. So those are those birds. They're like this, like that. There's a head, and they have those massive big like wingspans like that. In fact, actually, that's a pretty good drawing. That's what they look like. So this table was about the wingspan of these condors. Okay. And you've got to find out the 80th percentile, so when they put them all in order and so on, you can do all of that. But it says, why can't you work out the 90th percentile? Because when you work out 90% of the number of birds that they've got, it falls into this last group. And this last group there is saying wingspans greater than 3 meters. In other words, they don't give you an upper limit. So there's obviously a few birds with wingspans greater than 3 meters, and they didn't say 3 meters to 3.5 meters. They just said, so perhaps there was one bigger than 3.5 meters, a real massive bird with massive wings. Okay, so because you can't work out the bandwidth, you can't work out where these 11 condors fit in this particular group, and you, from that data, then you can't work out a position along it, the 90th percent. Okay, so there'd have to be a number there to work out, to divide the group up. So that's what you have to say in plain English, not the waffle that I've just given you, but that's why it doesn't work. Okay, so you need that upper limit. All right, so have a go at those. Hope you understood that. Hope you're getting more used to interpolation. Seems unusual. You know, this is continuous data, isn't it, here? This 20 to 30, 30 to 40 written like this. And you see it like that at GCSE, don't you? You never see continuous data like this written at GCSE where they've rounded off to the nearest, you know, kilogram or, you know, minute or whatever. And so we have to adjust the limits of the groups and know what our data is. We've really got to know what the difference is between discrete and continuous, and we really need to think about the groups. Remember, on the last lesson, there's a special case with age, isn't there? So look over that. There's different ways depending on how we do the limits of the groups, depending on whether it's discrete or continuous, and not just that, what sort of data it is. Okay, what the measurement is. Okay, so it's really, you have to think about it a lot more at A level. All right, hope that's okay. Finished on a nice one, finished on a nice picture for you. Okay, over and out.